Chapter 5.4 Factoring Special Trinomials. A polynomial that can be expressed in a form x squared minus y squared is called a difference of squares. Using what we know from the last 3 lessons, expand the following. Using FOIL, we will take the first term and multiply into the second bracket, and we'll do the same thing for the second term from the first bracket. A times a is a squared. A times negative b is negative ab plus ab minus b squared. We're going to collect the like terms. We have ab and another ab. So once you collect the like term, you'll see that these two terms cancel each other out. So we're left with a squared minus b squared. Using this pattern, you can always factor difference of squares, just like how x squared minus y squared equals x plus y times x minus y. We can replace x and or y by numbers, variables, monomials, or even polynomials. Let's take a look at example 1. Factor. Part A. Notice that the second term is a perfect square. This is same thing as 8 squared. Let's rewrite the expression. So x squared minus 8 squared. So we're just going to use this property to solve for the factored form. So I have x squared. I have perfect square here. Y is 8 in this case. Therefore, we just need to state it that the factored form of the difference of those two squares would be x plus 8 times x minus 8. Part B. And again, check for perfect squares. 36 is equal to 6 squared, and 49 is equal to 7 squared. So we can rewrite 6 squared times x squared minus 7 squared. I will rewrite this so that the base is a product. Using the power of a product rule, I'm going to rewrite this term. I can take out the two exponents here outside of the bracket. So this would be equivalent to 6x all to the power of 2 minus 7 to the power of 2. Now we have this form again. X from the formula is 6x in my example. Y in the formula is 7 in my example. So I'm just going to rewrite into factored form. I know the first term is 6x, and 1 is plus y, so 7, and then 1 is minus 7. Example 2. Factor. Part A. We have 3a cubed minus 12ab squared. Before we look for the special case of factoring, let's take out a common factor from each term. We have a coefficient 3 here and coefficient 12 here. Perhaps I can divide out 3 from each term. And I also see variable a in each term. I think I can take out 1a. So let's rewrite the second half. So 3a cubed divided by 3a is a squared. We're going to subtract 12ab squared divided by 3a is 4b squared. So this form doesn't look exactly like the form we want just yet, so we're going to modify it a little bit. Notice that we have 4 here, the coefficient, and 4 is a perfect square. So that is 2 squared. Let's rewrite. It's 3a times a squared minus 2 squared b squared in a bracket. Just like the previous example from here, we will combine this so that we can have a base as a product. So we can say that the second term is, in the bracket, 2b all squared. All right, so we're almost there. Now that we have a difference of square over here, we can rewrite them using the previous formula. We have this, and we can rewrite it into 2 bracket. We have a plus 2b times a minus 2b. Moving on to part B. X plus 3 all squared minus y squared. Recognize that x plus 3 is the base of the power. So consider that as a term. Then we already have a difference of squares. So we can go straight into writing our factored form. We have the first term as x plus 3, and we're going to add the variable in the second term, y, and then minus y over here. Moving on to page 11, perfect square trinomials. A perfect square trinomial is formed from the product of 2 identical binomials. Example, x plus y all squared or x minus y all squared. Let's take a look at x plus y all to the power of 2 case. So a common mistake people make is that you just distribute into each term and say, oh, x squared plus y squared equals that. So let's double check if that's true. So we have x plus y times x plus y. This, when we FOIL it, we have x squared plus xy plus xy and then plus y squared. This is equivalent to x squared plus 2xy plus y squared. This is not equal to this. So when in doubt, please double check by FOILing like this. Let's take a look at example 3. Factor. We have a hidden coefficient there, 1. So find the factors of 1. Must be 1 and 1. And secondly, let's check the factors of 4. Just choose 2 times 2. And when you cross multiply and add, you get 1 times 2 is 2, and 1 times 2 is 2. So you get 4, which equals to the middle term over here. So our factor is correct. Once we confirm that 4 is indeed the middle term, we can just create the bracket around the first row and the second row. And we'll rewrite it. So the factored form of that expression would be x plus 2 times x plus 2, which is equivalent to saying x plus 2 all squared. Part B, x squared minus 6x plus 9. Check the coefficient in front of x squared. It is 1 again. So we know the factor of 1 is 1 and 1. And then we'll have to find factors of 9. I like 3's, so 3 times 3 is 9. What we need to keep in mind is that the middle term is not just positive 6, it is negative 6. So there's only 2 cases where the product can be positive number. So product is positive because that's positive 9. So we either have 2 factors that's positive to give us a positive product, or we can have 2 negatives multiplied together to get a positive product. So you need to check that if the 3's were positive, if we cross multiplied, would our sum be negative? Probably not. It's actually positive 6 if this is a case. So we need to switch the sign. So we need negative 3's. Let's double check. We have 1 times negative 3 is negative 3, plus 1 times negative 3 is negative 3. So we get negative 6, which equals to the middle term here. So our factored form would be in a bracket like this. We have x minus 3 times x minus 3, which is equivalent to x minus 3 all squared. So this is it for chapter 5.